So today we are going to learn two new methods on how to solve our quadratics. Last class we learned how to solve by graphing and by factoring. Whenever you're solving a quadratic, you're looking for where the parabola hits the x-axis or where the y value is 0. These are called your roots, zeros, x-intercepts, and solutions. So today our method is both of our methods are going to deal with taking square roots. So the first one, it says solving quadratic using square roots. How do you solve a quadratic equation using square roots? Your first thing that you need to do is isolate the x squared term. Okay, what it means to isolate is get the x squared all by itself in the equation. Sometimes this is already going to be done for you, and sometimes we're going to have to manipulate the equation to get x squared all by itself. Next, you're going to take the square root of both sides of the equation, because what undoes squaring something? Square rooting it. So remember, a positive number always has two square roots, a positive and a negative. Okay? That means that if I were to take the square root of 9, the square root of 9 is both positive 3 and negative 3. And the reason for that is if I square 3, I get 9, but also if I square negative 3, I get 9. Okay? So that is why whenever we take the square root, we're going to put this little plus minus sign out in front. That's what that is, a plus minus. It's just a plus sign with a minus sign right below it. When do you use the square root method? So I love this method because I think it's relatively easy. The only bad thing about it is there are limitations on when you can use it. You only can use it when there is no bx term. So I only have my ax squared and my constant, my c. I don't have just an x term, my bx term. Okay? So we're not going to necessarily be able to use this method a lot, but if we don't have a bx term, I think this is definitely the easiest way to go. Okay? So looking at number 1. Do I have an x term? I have an x squared and I have a constant. I have no x term. So that's what lets me know I can use the square root method. So when we use the square root method, we need to isolate the x squared term. Well, my x squared is already all by itself on the left-hand side of the equation. So once I've already isolated the x squared term, I just take the square root of both sides. So put your square root around the x squared and your square root around the 25. Now, when you square root a squared, the square root and the squared cancel each other out. So I have x equals. When I take the square root of a number, I have to put a plus minus out in front, because when you take the square root of a number, it has two solutions, a positive and a negative. And the square root of 25 is 5. Okay? So I have two roots here, one at when x is 5 and one at when x is negative 5. So I could write my answer as negative 5, 0, because again, for our roots, the y value is always 0, and 5, 0. I have two different points where my parabola hits the x-axis. Okay? On Delta Math, the way they want you to do it, they don't like ordered pairs. And they also don't want x equals. So you have two options on Delta Math. You could either just type in, there's a little plus minus sign on Delta Math, so you could do plus minus 5, or you could do 5, negative 5, which is the same as negative 5, 5. The order of your solutions does not matter. I could flip-flop these and get the same answer. Okay? Normally on tests and on your quiz and on STAR, you're going to see it written as ordered pairs though. So that's why I like writing them as ordered pairs, and it also reinforces that these are points where the parabola hits the x-axis and the y value is always 0. Okay, number 2. I have an x squared term and I have a constant. I don't have an bx term, so I'm able to use this method. So my first step is to isolate the x squared term. I want this x squared all by itself on one side of the equation. So how do you get rid of a minus 100? We're going to add 100 on both sides. So negative 100 plus 100 is gone, and I have x squared equals 100. Now I have my x squared term by itself. So I'm going to take the square root of both sides. Remember, a square root and a squared cancel each other out. So I have x equals, if I take the square root of a number, I have to put that little plus minus sign out in front. And the square root of 100 is 10. So if you wanted to write these as points, you could write 10, 0 and negative 10, 0. So this parabola has two real roots at 10 and negative 10. That means it hits the x-axis at 10 and negative 10. Okay. Number 3. I have an x squared term, I have a constant term, and I have another constant term, which means I don't have a bx term. So I can use the square root method. Remember, when we use the square root method, you want the x squared by itself. So I need to get rid of my plus 7. So I'm going to minus 7. And I get x squared equals 81. Again, what you do to get rid of a square is you square root it. A square and a square root undo each other, so I get x equals, when you take the square root of a number, put the plus minus, the square root of 81 is 9. So my answer would be 9, 0 and negative 9, 0. Again, the order you write your solutions in does not matter, okay? So this one, I have a x squared term and I have a constant term. I don't have a bx term, meaning I can use the square root method. So what we're going to do is I need to get x squared by itself. This 6 is glued to the x squared, which means it says 6 times x squared. So the opposite of times is division. So I'm going to divide both sides by 6. And I get x squared equals 9. So now I have my x squared term all alone on the left. So I'm going to square root both sides. So I get x equals plus or minus 3. It's super important to put the plus minus outside or out in front, because if you just write x equals 3, that's only one solution. And I know that this has two solutions, a positive and a negative 3. Okay. Next one. I have negative 2x squared equals negative 98. So I need my x squared by itself. I don't have a bx term. I have an x squared term and a constant, so I can use the square root method. So I need to get rid of the negative 2. That says negative 2 times x squared, so I'm going to divide by negative 2. And I get x squared equals 49. Now I have my x squared term all by itself, so I square root both sides. These cancel, and I get x equals plus or minus 7. So my two solutions are 7, 0 and negative 7, 0. This method, like I said, I think is way faster than factoring, but again, you only can use this method whenever you don't have a bx term, which isn't going to be super, super common. Okay, looking at this next one. I have an x squared term, I have a constant term. So I don't have a bx, meaning I can use the square root method. Now this one has a coefficient and a constant. We always move our constant over first. So the way you get rid of a minus 45 is plus 45. So I have 5x squared equals 45. I'm not done getting my x squared by itself because I still have the 5 attached to it. So that says 5 times, so I'm going to divide by 5. So I get x squared equals 9. And the way you get rid of a square is you square root. So the square and the square root cancel each other out, and we get x equals plus or minus 3. So 3, 0, and negative 3, 0. Two more of this method. So I have an x squared term, I have a constant term, and a constant term. So I don't have a bx term, so I'm going to use my square root method. I need to get x squared by itself, so I need to get rid of the minus 5. So I'm going to add 5 on both sides. So I get x squared equals 1. Negative 4 plus 5 is 1. The way you get rid of a square is square root. The square and the square root cancel each other out, and I get x equals plus or minus 1, which means 1, 0, and negative 1, 0. Last one, and this one's going to be slightly different. It looks super similar to number 6, where I have an x squared term and a constant. So I need to get rid of my constant first. So I'm going to add 49. So I have 4x squared equals 49. Then I need to get rid of the 4 times the x squared. So I'm going to divide by 4. So then I get x squared equals 49 over 4 doesn't simplify, so I have to leave it 49 over 4. The way you get rid of a square is square root. The square and the square root cancel, and I get x equals plus or minus. So when you're taking a square root of a fraction, you're going to take the square root of the top, the numerator, and the bottom, the denominator. So the square root of 49 is 7. The square root of 4 is 2. So my solutions are 7 halves, 0, and negative 7 halves, 0. And there are my two solutions. Okay, so that is the square root method. Okay, you only can use the square root method whenever you don't have a bx term. Okay, now we're going to move on to completing the square. This method I think is a little bit harder. However, it is super procedural, super step by step by step. If you do the same steps every single time, you're going to probably actually like this method. Okay, so it says solving quadratics by completing the square. How do you solve a quadratic equation by completing the square? So you are going to move the c term, which remember is your constant term, to the right of the equation, so it's in the form ax squared plus bx plus, I'm going to put an empty box here because I'm going to have to add something there, equals negative c plus blank. And we'll talk more about what goes in those blanks, those in boxes. Okay. So notice my x squared and my x term are both on the left. My constant is now on the right. So then you're going to find b over 2 squared. This is what we call our magic number. Okay? So that number is going to be what you add in those two boxes. Now, the reason I have to add it to both sides is because when you're working with equations, what you do to one side, you have to do to the other to keep it balanced. Okay? So you're going to add the magic number needed to complete the square to both sides of the equation. Then you're going to factor the perfect square trinomial. Now, we did learn this whenever we did our factoring. I think probably a lot of people didn't love this. But if you are solving by completing the square, it's nice because you know once you complete the square, all of them are going to be perfect square trinomials, meaning it's going to follow our special pattern. So a squared plus or minus 2ab plus b squared equals a plus or minus b squared. So if you remember that, my first term's a perfect square, my last term's a perfect square. When I multiply those perfect squares and double, I get the middle term. That's how you know you have a perfect square trinomial. When we are completing the square, we are making our quadratic a perfect square trinomial. So it will always be in this form. So when I factor this, I just take the square root of the first term, it goes first, the square root of the last term goes last. This plus or minus is determined by that b term, okay? If it's a plus, there's a plus here. If it's a minus, it's a minus here, okay? Then you just do your parentheses squared, because that's what a perfect square trinomial is, when you have two binomials multiplied together that are the same, which is what parentheses squared means. So then you're going to take the square root of the perfect square trinomial and the square root of the value on the right side. Solve for both values of x, okay? So when can you use this method? Any quadratic can be solved like this. Now it's easier if a value is 1. Okay? So you can always use this method, but it's easiest if your a value is 1. Because if your a value is not 1, then you have to do something to make your a value 1, which we're going to do an example of that. Okay? So, looking at number 1, x squared x constant equals 0. So I need to move my c term to the right side of the equation. So instead of a minus 8, I'm going to add 8 on both sides to move my constant to the right. And then I'm going to have x squared plus 6x plus blank equals 8 plus blank. I'm putting those blanks on both sides to help me remember that's where my magic number needs to go. So out to the side, let's find our magic number now. Remember, your magic number is b over 2 squared. So here's your b. So 6 over 2 squared. 6 divided by 2 is 3. 3 squared is 9. So I'm adding 9 on both sides. Okay? So step 4 says factor the perfect square trinomial. So since I just completed the square, I now know that this is going to follow that perfect square trinomial pattern. So I know it's going to be parentheses squared. Then the way I figure out what goes in the parentheses, what's the square root of x squared? X, that goes first. What's the square root of 9? 3. That's what goes second. Then my b term tells me if it's a positive or a negative. And it's a positive here, so it's a plus there. Equals 8 plus 9 is 17. Okay? Then it says take the square root of both sides. Now the reason we can do this is I have parentheses squared. I need to get rid of that squared, and what undoes a square is a square root. So the square root and the square cancel each other out. So I have x plus 3 equals, again, when you take the square root of a number, just like we did on the last method, you need to put that plus minus out in front. Now 17. 17 is a prime number, meaning you cannot simplify it. If this was like 4, you would simplify, okay? So that square root can't simplify. Okay? So then what we need to do is we need to solve for x. So the way I get rid of a plus 3 is minus 3 on both sides. So then I have x equals. I can't actually combine these two terms together because this is a square root and that's a constant. So I'm just going to put my non-square root, my non-radical first, my constant first, plus minus square root of 17. Okay? So here I'm done. Okay? I can't combine these to make one term because they're not like terms. If I'm looking here, this represents two different numbers. It represents negative 3 plus the square root of 17, but it also represents negative 3 minus the square root of 17. So I still have two solutions here, okay? So my answer is negative 3 plus or minus the square root of 17, comma, 0. Another way you could write that would be negative 3 plus square root of 17, comma, 0, and negative 3 minus the square root of 17, comma, 0. This is the whole x value. This is your whole x value. So I just took this value and split it up into two separate numbers. But it is okay leaving it like this. You just need to know that that does represent two different solutions. One where you're adding the square root of 17 and one where you're subtracting the square root of 17. Okay? So let's look at number 2. X squared x constant. Okay, so I need to move my constant to the other side. The way you're going to get rid of your plus 2 is minus 2. So I have x squared plus 6x plus blank equals negative 2 plus blank. Again, I like putting the plus blanks on both sides to help me remember that that magic number has to be added to both sides. Now the reason you're always adding it is because when you square any type of number, positive or negative, it's always going to be positive. Okay, so my magic number is b, which is 6, over 2 squared. So 6 over 2 is 3, squared is 9. So my magic number is 9. So what that is doing is it's making my trinomial over here a perfect square trinomial, which lets me be able to factor it.
Teachers, please pardon this interruption.
Hold on really quick, guys.
I sent out an email about attendance procedures for today until the error gets corrected. If you don't mind checking your email and completing attendance in that method until we hear otherwise. Thank you.
So whenever we're using this method, I know this is going to be a perfect square trinomial. So take the square root of the first term, take the square root of the last term, and then this tells me it's a positive. Equals negative 2 plus 9 is 7. So now I have my parentheses squared. The way you get rid of a parentheses squared is you square root. Square root and squared cancel each other out, and I have x plus 3 equals plus or minus the square root of 7. Now, 7 is also prime, so this can't simplify. Okay, so I need to get x by itself. I need to get rid of the plus 3, which means I'm going to minus 3. I get x equals, these are not like terms because this is a constant, that's a radical. So negative 3 plus or minus the square root of 7. So again, I can write it as one ordered pair, even though that represents two solutions. Or I can write it as negative 3 plus the square root of 7, comma 0. And negative 3 minus the square root of 7, comma 0. Either of those are correct ways to write your solutions to this quadratic. So if you notice, these answers for these last two problems are kind of ugly. They have square roots. Anytime you have square roots in your answer, that means that these could not be solved by factoring, okay, or by graphing. So that's why we have to learn other methods, because you're not always going to be able to solve by factoring or always solve by graphing. Okay? So the next one. Well, looking here, this is already set up where my constant's on the right. But I'm going to rewrite it where I have a plus blank. So that way I remember I need to add my magic number to both sides. So So my magic number, how do I know what my magic number is? It's just a formula. It's b over 2 squared. So negative 6 over 2 squared. So negative 6 over 2 is negative 3. Negative 3 squared is 9. Okay, so again, I now know this is a perfect square trinomial. So it's x, square root of the first term goes first, square root of the last term goes last, and then this tells me that it's going to be a minus in between the two terms. Equals, what's negative 6 plus 9? And that's 3. So then I now have my parentheses squared. The way you get rid of your parentheses squared is you take the square root of both sides. Square root and squared cancel out, and I have x minus 3 equals plus or minus 3. Oh, sorry, square root of 3. 3 is a prime number, meaning you can't simplify the square root of 3. Okay, so now I just need to get my x by itself. So I'm going to add 3 on both sides, and I get x equals 3 plus or minus the square root of 3. Again, that's two solutions, but I'm just going to write it this time as one ordered pair, even though I know that that's representing two solutions. One where it's 3 plus square root of 3, and one where it's 3 minus square root of 3. Okay? This one we're going to have to do a little bit more work on because our square root's going to be able to simplify. So it's x squared x constant equals 0, so I need to move my 8 to the other side because you always have to have your constant on the right-hand side. So x squared minus 4x plus blank equals 8 plus blank. Then we're going to find our magic number. And that's b, which is negative 4 over 2 squared. So negative 4 over 2 is negative 2. Squared is positive 4. Remember, when you square a positive or square a negative, it always becomes positive. So now we're a perfect square trinomial, so I'm going to do my parentheses squared. Square root of x squared goes first, which is just x. Square root of 4 goes second, which is just 2. My b term tells me that it's a minus, and 8 plus 4 is 12. So then we need to get rid of our square. The way you get rid of a square, square root, these cancel. So I get x minus 2 equals plus or minus the square root of 12. Now, 12 simplifies, so I'm going to do my factor tree out to the right. 12 is divisible by 2 and 6, 2 is prime, and 6 is divisible by 2 and 3, 2 is prime, 3 is prime. So I'm going to rewrite this as x minus 2 equals plus or minus the square root of 2 times 2 times 3. So then I'm looking for a pair. I have a pair of 2's that get to come outside. Whenever I rewrite this, notice how I'm still keeping the plus minus out in front. 2 times 2 is 4. The square root of 4 is 2. The 3, you can't take the square root of 3 and get a whole number, so it has to stay under the radical. So again, when the radical, the number under the square root, can be simplified, you need to do it like we just did here. Okay, so now that I've simplified my radical, I need to get x by itself. The way you get rid of a minus 2 is plus 2. And then I get x equals 2 plus or minus 2 square root of 3. I can't add the 2 and the 2 because this 2 has a square root of 3 and this doesn't, so they are not like terms. So it's 2 plus or minus 2 root 3 comma 0. Again, notice that is your x values. How many are there? You have 2 x values there. One where it's 2 plus 2 square root of 3 and one where it's 2 minus 2 square root of 3. Okay, so number 5 looks a little bit different because now I have an a value. You can never complete the square when you have an a value. So what I need to do is I have to divide out that a value. So I'm going to divide everything by negative 3. Negative 3 divided by negative 3 cancels out, so I just have x squared. 24 divided by negative 3 is negative 8x. Negative 42 divided by negative 3 is plus 14. 0 divided by negative 3 is 0. Again, you cannot use completing the square until you get rid of your a value. A only can be 1 when you are completing the square. Okay? So, now I need to move my constant over. So x squared minus 8x, sorry, I should write the minus 14 below it, plus blank equals negative 14 plus blank. So then we need to find our magic number, which is b, which is negative 8 over 2 squared. So negative 8 over negative 2 is negative 4. Negative 4 squared is positive 16. So I'm adding 16 on both sides. So I then know that this is a perfect square trinomial, so I'm going to do my parentheses squared. The square root of x squared is x, the square root of 16 is 4, and it is a minus. Then I get equals negative 14 plus 16 is 2. Now I need to get rid of my square, so we square root, square, so then I have x minus 4 equals plus or minus the square root of 2. 2 is prime, so there's nothing I can do. So I need to get rid of my minus 4, so I'm adding 4 on both sides. So then I get x equals 4 plus or minus square root of 2. So then it's 4 plus or minus square root of 2, comma, 0. So once you get the hang of it, I think that completing the square isn't too bad, okay? Things you have to remember is that when you complete the square, you have to add that magic number to both sides, okay? You also need to remember that a has to be 1, so we have to divide out our a value if it's not, okay? Last one. X squared x constant equals a constant. So I have two constants here, but that's okay. I'm just going to move my 91 over to the right because I want my constants on the right. So then I have x squared minus 4x plus blank equals 98 plus blank. So then I need to find magic number. Negative 4 over 2 squared. So negative 4 over 2 is negative 2. Negative 2 squared is positive 4. So add 4 on both sides. So now I have a perfect square trinomial. So I know it's going to be parentheses squared. Square root of x squared is x. Square root of 4 is 2. And it's a minus equals 102. 98 plus 4 is 102. Now the way I get rid of my square is square root. So the square and the square root cancel, so I have x minus 2 equals plus or minus the square root of 102. Now 102 is a pretty large even number, so we're going to factor tree it. If it's even, I know it's divisible by 2, so 2 and 51. 51 is not even, but it is divisible by 3, so 3 and 17. Are any of these numbers the same? Since they're not, you can't simplify this. If I were to write this out, there's no pairs to circle and go outside. So I'm going to just leave it as x minus 2 equals plus or minus the square root of 102. Now, again, if your radical is a large number, especially if it's a large even number, you're going to want to see if it does factor and if you have pairs that are going to match and help you simplify your radical. If not, put it back together and just leave it as is. Okay, so then I have to get rid of my minus 2, so I'm going to add 2 on both sides. So then I get x equals 2 plus or minus the square root of 102. So I'm going to write that as an ordered pair because, again, this is where your parabola hits, touches, crosses the axis. Remember, those are called your roots, zeros, x-intercepts, and solutions. Okay? So So we are done learning our two methods for today. You're allowed to use the square root method whenever you don't have a bx term, okay? You can use completing the square all the time as long as you can divide out your a value, okay? I hope that y'all enjoyed this lesson and reach out to your teacher if you have any questions. Have a great day.